Okay, good morning, children. Today we are doing a very important property of alkenes, that is addition and reaction of alkenes. A simple example of addition reaction is CH2 double bond CH2. It is ethene plus hydrogen. Now hydrogen, which is H2, we can write it like this: H bond H. And in addition reaction, what happens? One hydrogen will get attached to this carbon, another hydrogen will get attached to this carbon. And double bond will become single bond, and we get from ethane. So during addition reaction, a unsaturated compound, unsaturated because there is carbon-carbon double bond, unsaturated compound becomes saturated in an addition reaction. Now, this terms you have to know for addition reaction. The substance which is getting added, it is called addendum. Addendum. And where it is getting added, it is called substrate. Substrate. And the product that is formed by addition reaction is called adduct. Okay, now ethene can be of two types. One is symmetrical, like alkene can be of two types: symmetrical alkene and unsymmetrical alkene. Like this is an example of symmetrical alkene. Say CH3CH double bond CH3. It is also example of symmetrical alkene, because you see on the other side of double bond it is same. So in such cases, suppose now we are considering say addition of say HBr. It was addition of hydrogen. Now HBr also can be added. HBr forms HBr means we call it your halogen acid. This is a halogen acid. So what will happen here? Here again, one H will get added here, one Br will get added here, and we get the product CH3CH H CH Br CH3. So this is the product that is formed, and if you want to name it, IPAC name, so it is 1, 2, 3, 4. It will be 2 bromo butane. Now, one thing about addition reaction is very important. You should know that here there is carbon-carbon double bond. This carbon-carbon double bond, and double bond is made up of a sigma bond and a pi bond. Pi bond is very weak and sigma bond is very strong. So during addition reaction, what happens? The pi bond breaks. The pi bond breaks, and that's why the addendum gets added. Okay, now let me consider a unsymmetrical alkene. Say CH3CH double bond CH2. Okay, which is propene. Propene. It is an example of unsymmetrical alkene. So if we add HBr, if we try to add HBr, now you see there are there are two possibilities. There are two possibilities. What are the two possibilities? Suppose in one case Br gets added here. Br gets added here. So this is possibility number one, suppose. And say in another possibility, Br is getting added here. That is suppose number two possibility. So of course when Br gets added here, H will get added here. And in other case, if Br gets added here, H will get added here. So we can expect two products here. So I am writing both the product. If it adds in this way, one way, so Br coming here, so it will be CH3, CH, Br, and H will get added here, so this CH2 will become CH3. So this is that will happen. On the other hand, if Br gets added like this, then it will be CH3, CH2, CH2, Br. So these are the two possibilities. Now, what is actually seen is that this one is formed. This one is formed, and this one is not formed actually. Or we can say, this one is formed in large amount. It is major product. It is major product, and very small amount of this can be formed. This is minor product. Minor product. So like this thing happens, in case of unsymmetrical alkene. In case of symmetrical alkene, you can easily make it out. We get only one product. Okay, now how the addition will take place in case of unsymmetrical alkene? Okay, to understand that, to get a guideline, there is one rule, very important rule. It's called Markovnikov's rule. Markovnikov's rule is very important. So the rule, you can find the statement in your book. It says that the negative part of the addendum gets added to carbon having lesser number of hydrogen. Now you see HBr, now which is the negative part of HBr? Since bromine is more electronegative, so bromine is negative part, delta minus, whereas H will be positive part. So Markovnikov rule says that the negative part of the addendum will get added to carbon having lesser hydrogen. Now this carbon you see has one hydrogen, this carbon is having two hydrogen. So this carbon is having lesser hydrogen, so Br will get attached here and we will get this product. This is also called Markovnikov product. It is also called Markovnikov product because it is following Markovnikov rule, and we may get very small amount of this product, and if this product is formed, and it is called anti-Markovnikov product. Anti-Markovnikov product. To illustrate this rule, let me consider another example. Say CH3, CH, double bond, CH2, and you all know this is water. Water can be also added to alkene. This addition takes place in presence of acid as catalyst. H plus is acid. And now what will be the Markovnikov product? For that you have to know which is the negative part of the addendum, and the negative part is OH minus. OH is the negative part of the addendum and H is the positive part. So this OH will get added here, and we get a product CH3, CH, OH CH3. Now we have to discuss why addition takes place in Markovnikov way. We have to explain. We can do so by a mechanism. So we are doing now the mechanism of Markovnikov addition. Mechanism of Markovnikov addition. So why we get these as a immediate product? What is the explanation for that? That we are doing it now. So the mechanism. So let us consider this reaction only. So this is CH3 CH double bond CH2 plus HBr. Then what will happen is this HBr will ionize into H plus and Br minus. It will ionize into H plus and Br minus, and this H plus will attack. H plus will attack. Suppose H plus is attacking here. H plus is attacking here. Now why H plus will attack first? It is because this molecule is rich in electron, because there is a pi bond, pi electron cloud. So since this is rich in electron, a species which is poor in electron should attack first. That's why H plus is attacking first. Br minus is not attacking first. So H plus, when it attacks here, now you have read a phenomenon called electromagnetic effect. When H plus attacks here, then what happens is there is a pi bond electron. Pi bond electron comes over here. The moment H plus attacks here, the pi bond electron comes this side. Because attacking means what? A bond is going to be formed, and for bond formation, electron is required. H plus does not have electron. So H plus comes here, pi electron comes this side simultaneously. So this is called electromagnetic effect, and we will get this thing CH3, CH, CH2 and H. So this attacks here, this pi electron comes this side, and when this pi electron comes this side, and you can see, you can calculate the formal charge here, if carbon will become positive. So when carbon is positive, it is called carbocation. So carbocation is formed. Carbocation is an intermediate. So this carbocation is formed plus Br minus. Okay. Now suppose this is one group. Okay. Now there is another possibility. There is another possibility, that is, if suppose this H plus is attacking here. If it is attacking here, is that this I am writing it possibility 2. Okay, this is possibility 1 product already written. If H plus attacks here, then in the same way the pi electron will come this side. And pi electron will come this side, and the product carbocation we will be getting will be CH3, CH8 CH2 plus. I'm writing it here that it will be better to understand. This is one pathway, this is two pathway. So carbocation is formed. There are two possibilities. Now you see this carbocation, it is attached to two other carbon, one this side and one this side. So this is called 2-degree carbocation or secondary carbocation. And this carbocation, you can see it is attached to only one carbon, this side. So this is 1-degree carbocation or primary carbocation. And it has been discussed before that the order of stability of carbocation, the order of stability of carbocation is carbocation. It is 3-degree carbocation more stable than 2-degree carbocation, which is more stable than 1-degree carbocation. The order of stability of carbocation, which can be explained by Plaza effect. We can explain by Plaza effect. It can also be explained by hyperconjugation, that we have already done. So anyway, so you can easily make it out of these two possibilities, which one will actually take place. Since it is 2-degree more stable, since it is more stable, this is less stable, so this one will be formed. This one will not be formed. So we are considering this for the next step. Okay, in the mechanism, this is step 1, and step 2. In step 2, what will happen is we start with this here. So CH3C8 plus CH3. And now this Br minus will attack. Naturally, Br minus will attack at this carbon. Br minus will attack at this carbon. So if Br minus attacks at this carbon, so naturally we will get this as a product, which Markovnikov has said. So when this attacks with this, so we get this product. So this is a mechanism of explanation of Markovnikov addition. In your exam, Markovnikov rule and this mechanism will be very important. Now I am going to say one more thing, that is this reaction which we have talked about, addition of each Br, it becomes different. It becomes different if organic peroxide is present in the reaction mixture. If organic peroxide is present, then addition takes place in another way. So that we are going to discuss now. So this reaction that we have to discuss, it is CH3C8 double bond CH2, unsymmetrical alkene, suppose HBr, and if organic peroxide, I am writing in short OP, if organic peroxide is present, then then we get the product opposite of Markovnikov's rule. We get product opposite of Markovnikov's rule, and this thing is called anti-Markovnikov addition. This is called anti-Markovnikov addition, and this phenomenon is called peroxide effect. Peroxide effect, also called Kharash effect. So naturally, we have to understand by mechanism why like this happens. So here I am discussing the mechanism of peroxide effect. So the mechanism is like this. So we have to take a organic peroxide. An example of organic peroxide is this one. This is the organic peroxide, because peroxide means a substance which has got OO link or O bond, is called a peroxide, is said to have peroxide linkage. So this is a organic peroxide. Its name is benzoyl peroxide. Okay, so what happens here, is that this there occurs homolytic fission. Okay, you have studied about cleavage of bonds. You have studied about homolytic cleavage. You have studied about heterolytic cleavage. Here it takes place in homolytic way. This bond breaks, and we get from one mole we get 2 moles of C double bond O dot. So when O dot means here we are getting as intermediate free radical. Free radical we are getting, and if I complete the lone pair here, there will be also 2 lone pairs here. So this oxygen also has got these 2 lone pairs. If I draw the lone pair here also, it is like this. So this bond breaks and it becomes like this, and there won't be any charge. You can see there won't be any charge here. It's neutral but having unpaired electron. That's why it's free radical. Now this stabilizes into more stable species. How it got stabilizes? There are 2 electrons here, and now this there occurs your homolytic fission, and what happens is this electron comes over here, this electron comes over here. Carbon dioxide is formed. Carbon dioxide is C double bond O, C double bond, so carbon dioxide. So this carbon dioxide gets removed. And that's why minus CO2, and this phenyl free radical will be formed. Phenyl free radical. This phenyl free radical is formed. This can be also written as C6H5 dot. So this step is formation of phenyl free radical. So naturally you can make it out, this reaction, this mechanism, it's a free radical mechanism. It's a free radical mechanism, and you have studied in a free radical mechanism there are 3 steps. The first step is called initiation. First step is initiation. So this is our initiation. And the second step is propagation. Second step is propagation. So what happens during propagation is this free radical though I am writing it here, this unpaired electron is actually on carbon. So this will now react with HBr. HBr is addendum in this reaction, and what will happen is again here there will be homolytic fission, and we will get bromine free radical plus C6H6. So there is formation of bromine free radical. And this bromine free radical, what it will do, now we have to take this compound. So this bromine free radical will attack. There are 2 possibilities of attack. This can attack here. Suppose it is, if I call it as your 1, and it can also attack at here if I call it as 2. So both the possibility I am showing it here. Possibility number 1, if Br dot attacks here, when Br dot attacks here, that means the bond with Br will form here, and then what happens is the pi electron, this pi electron which is having 2 electrons, this pi bond breaks, and this electron gets involved in the formation of bond. For formation of bond, 2 electrons are required. One is this one, and another will be from this one. And one unpaired electron will be left over here. This is a very important thing that you understand. So I am telling it once again, Br dot will attack here, this pi bond will break, 1 electron will come and help in the formation of bond with Br, and another electron will be left over at C. So this one will result CH3, CH dot, CH dot, and CH2 Br. So this Br dot has attacked. This is possibility number 1, and if Br dot attacks here, then possibility number 2 will be CH3, CH, Br, and CH2 dot. So this free radical is formed now. You can see that free radicals are also of different degree. This is a 2-degree free radical, or secondary free radical, because with this carbon which is having free radical, there are 2 other carbon on other side. So it's a 2-degree free radical or secondary free radical, and this one is a 1-degree or ternary free radical. And out of these 2 free radicals, which one is more stable? 2 degrees more stable. So this is more stable. So that means out of these two possibilities that we have written, this one will not take place. So I am putting it cross here. So this one is going to happen in this propagation step. Now after that, what will happen? It is also within propagation. So we will start with this now. So CH3 CH dot CH2 Br. So this radical will attack on another Br molecule. Again, this homolytic fission will take place. And this H dot will get attached here. This H dot with C dot will form a bond. So it is CH3 CH8. So bond has been formed. CH2 Br. And what will be the another species formed? That will be Br dot. So you see, in this propagation step, we have got the product that we expect. We have got the product, and then what happens with this bromine free radical? This bromine free radical that is formed here will act on another molecule of propene. It will form again this one. This one will again form another product. Br dot will be formed. Again Br dot will act on another propene. In this way, this this process will continue. So Br dot will react with more and more of propene, and more and more of this compound will be formed. It keep on going. That's why it is called propagation. And free radical mechanism has a third step also, that is called termination. So I am writing the termination step. Termination. Termination means it is the disappearance of free radical. So the termination that can happen is this Br dot can combine with Br dot to form Br2 molecule, and this phenyl free radical that is formed, that also can form like this C6H5 dot can combine with C6H5 dot to form like this. So termination means disappearance of this free radical. So this is the mechanism of peroxide effect or Halash effect. Now, a very important thing here is that this addition that we have talked about, it happens only with HBr. It doesn't happen with other halogen acid. It doesn't happen with HCl. It doesn't happen with HI. So, why it doesn't happen with other halogen acid? Why it happens with only HBr? That we need to understand. What I mean to say is that that CH3 CH double bond CH2 plus HBr in presence of organic peroxide. We know this is how it gets added. Just now we have discussed this one. But if it is other halogen acid, say CH3CH double bond CH2 plus say HCl in presence of organic peroxide. Now here anti-Markovnikov addition does not take place. It happens Markovnikov way only. So here we will get the product. We will get the normal product, Markovnikov product. Or for example, if you consider CH3 CH double bond CH2 plus HI in presence of organic peroxide, then you will get CH3 CH I CH3. So with HCl, with HI, normal Markovnikov addition takes place even in presence of organic peroxide. So why this happens? Why this happens? I am not going to tell here. You first find out yourself. Okay, why anti-Markovnikov addition happens only with HBr? Why it doesn't happen with other halogen acid? That means with HCl, with HI, the product is going to be same whether we use organic peroxide or whether we don't use organic peroxide. But with HBr, the product will be different if we use organic peroxide and if we do not use organic peroxide. So children, this is what about mechanism of addition reaction to alkenes. This much for now. Okay, we will be doing more about alkenes in our subsequent classes. Till then, have a good day.